Okay, so the chapter here is quite clear because you see a sector. In fact, they even say it's a sector. Okay, so arc length, area, sector, chapter. Now is the perimeter. So just like mensuration questions, you just got to be clear what the perimeter is, and that is a matter of breaking it down. Okay, so the perimeter is, what's the definition of it, Shakir? Yeah, in your own words, what do you think? What does perimeter mean? The outside, going one whole round along the length for the outside. So it's made up of 1, 2, and 3 parts. Clearly, part 1 and part 2 they are circled on the thing are obvious, right? They are the what of the circle? Or what lengths are these? 1 and 2 here.
3 lengths. Radius.
They are both radius of 8, right?
Yeah.
So 1 and 2, easy lah. So what is the third part here? Circumference, in other words, the crust. In other words, arc length. Now wait. The angle is given in what measurement? Degree. So let's use the degree formula. Yes. Theta over 360. Are we finding area or the circumference here? So times 2 pi r, which is 8. Okay? So you got to be clear. Okay, degree. So I'm using this particular formula with your appropriate radius. Okay, what's the value here? 20.5.
I passed everything also plus the 8.
Oh, this is everything, ah?
Yeah.
10.5.
Thank you. I needed that. So the total perimeter.
10.8 plus 8 plus 8.
Yes. So 10.5 plus the 2 radius that we take down here, 8 plus 8. So 26.5. Okay, so basically you want to calculate this shaded area. First of all, it's a sector again, so it's clear cut what topic this is. But this shaded area, is it directly the area of the sector or not? No, yes? Okay, it's not the whole sector, right? It's not the whole like pizza slice. It's a part of it. Okay, so if I draw a representation here, I did this in the class previously the other day. If I wanted to find this, it's actually like primary school maths. It's actually taking the whole sector minus what? The triangle that you see earlier on. Oh, this side here. It'll give me the remainder behind, right? So individually, again, a problem of a big problem broken down into 2 small problems. What is the area of sector?
Area is always theta over 360 times pi r square.
Shami, why do I use that one?
Because we want to find the area of sector.
But what's the thing that will tell me to use that formula? Because there's 2 formulas, right?
Sector. Area of a circle.
What is the clue here? 112? The degree. It's the angle is in degrees. Hence, we will use the theta over 360 version. Okay? Which is 112 over 360 times what?
Pi r square.
Not 2 pi r, ah?
No.
15.
Okay, pi 15 squared. So, area of sector for the one, this shape above. How about our triangle here?
Half AB sin C.
Yes, because actually you have 2 radius here, which will encompass this angle here that I'm drawing in black here. Half AB sin C. So actually it's half r times r, so I'll just write I'll square the sine of 112 degrees. Okay, please make sure your calculator is in degree mode when you key all this in. Okay, so actually I've already done all the working on the side.
116.
What's the value?
116.
116 monkeys. Cm cube. Cube or square, guys? This is the area, so it's actually just square. That's it. Okay? So I repeat again, there are many different levels. The first level of finding the perimeter of the shaded sector. Again, break it down first. Perimeter of the shaded sector means this one plus this one plus this one, which is actually very similar to the previous one we did. That's the first part. That's the first level. Second level of difficulty, however, is this thing here in the form of P pi plus Q. What does this tell us when you see the pi there? What does it tell us actually?
In terms of pi.
Yes. Usually when I do my calculation, where will I see pi? Do you remember in your formulas, do you see pi or not? Yes, right? So basically if I did parameter of the shaded sector, if I do arc length, right, where will I see the pi? Arc length.
2 pi r.
The 2 pi r. So if I went to press the pi into the calculator earlier on, right, will I start to see the pi at the end?
No.
No, right? So what is the instinctive thing to do here?
Just leave
How should I deal with the pi?
leave the pi.
Do not press it into your calculator. Okay, so let's see, take a look at how to deal with it. So arc length, what's the formula again?
Theta over
Theta
360
over
times
360 is 130 over 360.
130 times 2 pi r. Okay, stop. I have to ask you one more time. How do I know I definitely have to use this formula? This version.
You have to find the d.
The angle is in degrees. Okay? Alright, so now I look at this carefully. So what should I press into my calculator to find this part 3 arc length, guys? Be careful, we don't want to have the pi there, right? So let's key in everything else except the pi. So I will have pi at the end. So what am I going to calculate? 150 over 360 times 2 times 6. You just press that.
5
5 pi.
Hence, the answer is simply 5 pi. Exactly. We leave the pi alone. Treat it as if it's a x. You know, like 5x, 3x. You will leave it as like a variable like that. It's an object we don't want to touch.
So it's like algebra but not finding.
Yeah, you can think of it something like that. Don't evaluate it in your calculator.
Okay. Bahasa dapat.
Shakir, okay or not? Or you do not know what I mean? Pi is something you can press in a calculator, right? But because of the way they ask you at the end, they want to see the pi there. Imagine if you really key the pi value into your calculator, can I get it? Can I see at the end? I won't, right? So I'm going to leave the pi alone and not evaluate it here. I'll leave it as 5 pi as my arc length here. Now to continue, the parameter is a matter of adding things up, right?
We have another 2 sides.
Yes, which is uniquely the radius of the circle. So actually it's 6 plus 6 plus
5 pi.
arc length, which we found to be 5 pi. Please resist the temptation to again press the pi again. We are very close to the p pi plus q already, right?
5 pi plus 12.
Yes, isn't it just 5 pi plus 12? And that is the answer that we're looking for. What if